Hello and welcome. My name is Tiffany and I'm with Techopedia, your go-to tech source for professional IT insight and inspiration. Today, we're proud to share how AI is reshaping inventory management, presented by AltaML. Just a reminder, today's webinar is being recorded and we will send out a link to the recording and slides shortly after the presentation. Don't forget that this webinar is for you, the audience. So please get your questions into the Zoom Q&A console as we go, and we'll get to them at the end of the presentation. I will now turn it over to our speakers to introduce themselves and get into the presentation. So with that, Brent, please take it away.
Thanks, Tiffany. Hello, everyone. My name is Brent Willett. I'm the supply chain leader here at AltaML. I've spent my entire career in supply chain between industry and advisory with the Big Four services. So really excited to share our perspectives, some examples and use cases around how AI is really shifting inventory management practices, including the demand forecasting, or what we'll see as demand sensing. So appreciate your time, and I'll pass it over to Rick to introduce and kick us off.
Yeah, Rick Makos, I'm Managing Director here at AltaML. I've been in the data and analytics business for 30 plus years. I've had the great pleasure and opportunity to work with many companies in different industries, from financial services, retail, manufacturing, federal, state, and provincial governments. So I've got a lot of experience working with clients to have successful data and analytics implementations. Supply chain and demand chain forecasting has been a big part of that as well. So I too am super excited to be here with you, and thank you in advance for your time and all your questions. And I'm looking forward to interacting with you at the end of the presentation on the questions. So let's get started. As you know, AI has had a significant hype over the last little while. In December of 2021, McKinsey came out with the State of AI, a really good summary. Interesting enough, when you look at supply chain management, when it comes to, I call gross margin improvement or gross margin enhancement, supply chain is right up there, where not only the percentage of respondents saying they had a positive improvement in gross margin, but in the range of 10 to 15% improvement is the vast majority, over 55% of the respondents said they had significant positive gross margin enhancement and optimization because of investing in AI in the supply chain. So we've continued to see year after year supply chain executives investing in AI, and the ones that do are reaping a more efficient infrastructure and driving enhanced gross margin within their business. Good news is it's also driving significant revenue increases as well. Again, supply chains are right up there with not only engagement of people saying that they've used AI to have positive revenue enhancements as well. And again, you're well into the 55% range of companies that have grown their revenue by somewhere between a little less than 5% to over 10%, which obviously is just huge, directly tied to investments in AI. So let's find out exactly what those investments can be, and I'll pass to my colleague Brent to walk you through examples and some of the key challenges and enablers that are taking place in supply chain.
Thanks, Rick. And so I just wanted to give a little bit of context on this slide. You'll see a couple numbers below. Those are from recent industry surveys, but really supply chain has never been in the spotlight like we are today. As a supply chain professional, I love it. And it's also a little bit of a challenge if we don't have the right tools. The large one has been the global disruption of product flow. There's the pandemic side of things. There's floods in BC. There's all sorts of inputs coming into why inventory has been a challenge, and a lot of the media and a lot of the conversations that have been happening right now is, are we in this major shift between a just-in-time approach and a just-in-case approach? And so part of the context as you're thinking of supply chain leaders and within your organization is, where do we fit within that balance of having just enough inventory for product flow while not wanting to stockpile? And so today we'll talk about some of the tools and how we perceive, how that balance can actually be achieved. Additionally, adopting a resilient inventory approach. Another great word that we've all heard over the last year is supply chain resiliency. And so resiliency at at the bottom level up is understanding your inputs, which then allow you to make predictions and scenario plan, and then really drive your risk mitigation techniques. So we'll look a little bit about resiliency, and then talent is for your own organization. How are you taking on the talent? How are you upskilling and enabling your current talent to support all of these digital innovations? So there's it's industry agnostic on some of these challenges that we're having, and so we'll talk about that. But really, the three takeaways that I want you to come away with and have a different perspective are those on the next slide here, and those would be resiliency. So we're going to try to define resiliency, and not just at that abstract level, but how can we go about having inventory visibility and using it for scenario planning. So inventory visibility might be at the most simple side, understanding quantities and price at a specific location at a SKU level. Is it one step further around knowing what non-moving inventory you have, knowing what excess inventory you have, knowing where that excess inventory you have? Or is it kind of at the latter stages around taking in all that external data and be able to scenario plan around what if statements at a very high level within your network? What we want to also do is take away from, it's no longer just demand forecasting. You're going to hear a lot of different vernacular, if you will, out in the market around demand sensing and demand shaping. And so we'll talk about what that actually means today and how AI is being applied. And then all of this rolls up really into the unifying data and the working process to make sure that the data is there in order to enable all this scenario planning and demand sensing, and where AI is really taking our industry. So if we can jump to the next slide here, it's really about shifting strategy. And so let's talk about, at a high level, predictive analytics. We've all used it. We've all used that wonderful Excel tool to do most of our forecasting. And so we're trying to actually define now what's the difference between traditional forecasting and that demand sensing. If you think of driving a car and starting a car, we have all the data and we know what we need to do to start that car. And we also have rules. We can program the rules around taking that data and put the key in, turn the key, and the car starts. That's kind of what traditional forecasting is. We have all of our data inputs. We have columns within Excel or within our predictive models, and it'll give us the answers. So we set those rule-based to get those answers. And within those forecasts, will be plus or minus 5 or plus or minus 10%. Demand sensing kind of takes over that. And so if we start the car and we need to back up into traffic and we need to start driving the car, well, now we have environmental factors. We have weather, we have traffic, we have red lights, rules, laws, regulations that we all have to start encompassing. And so demand sensing takes all the external data sources, as well as our internal data sources, creates, takes the answers and actually creates rules, because we're not going to be able to create the rules to give the answers. We're going to have to get the answers in order to inform what the rules should be. And then those rules will continuously update and cycle and, if you will, learn what the demand should be predicated on what all these external data sources are. So we're shifting the way of actually forecasting from just that rules base to taking in a whole bunch of data, allowing a machine, AI, machine learning, to learn and provide that best outcome, understand what that outcome is, and then put it back into our model. Because at the end of the day, there's just too many data inputs and data sources. So on the next slide, this is where we start talking around demand visibility and what does demand sensing and what is a resilient supply chain. These are just some examples, but our Excel model would typically have these internal data sources for the most part. They don't include these external data sources. And so we are now including external data to realize more accurately what our forecast should be. We're going to have different models. These are just a couple of examples, whether it's regression or boosting methods to remove bias. And that gives us kind of the inventory demand sensing side. So what do we mean by sensing? Well, it's understanding what the market requires and then preactively or proactively sending the inventory to those locations. It's understanding if there's inclement weather that's on the horizon. We'll be able to shift our inventory and redeploy our inventory beforehand. So now if we understand all of these data inputs, we can actually start to understand which input and what change is going to impact our forecast. So if we have all of these inputs and we can relay this into a model, then we actually start having visibility into what all the inputs are and how the model is going to react by changing one of these inputs. So that's scenario planning. And then through scenario planning, it'll actually get that visibility and that resiliency because we can actually go through the risk mitigation process. So when we talk about supply chain resiliency, it's much more tactical than just, let's throw some extra inventory into our system. It's, okay, let's understand what all the components are that impact our inventory, which here's a subset of. And then it's being able to use a platform through AI to automatically compute what those changes are going to be and how it's going to impact us. So again, what are lead times going to be if a container falls off a ship? We'll be able to actually understand the impact, and then we can make proactive decisions on how to get to how to fulfill our orders. We go to the next slide. Okay, and now we have all of those inventory components. The one thing we want to make sure we understand is that with classic forecasting models, we're doing the best we can. We're getting our average inventory. And so one of the things that we're trying to reduce here is the variability within each of those inputs. And so if we're constantly looking at the average inventory input, and we're going to guess ABC around what the impact is going to be, we're going to kind of get plus or minus 10-20% around variance error. But if we have the visibility, we understand what the variance is, and we can manage those exceptions a lot tighter, we're going to continuously reduce our forecast error. Okay, and by reducing our forecast error, we're going to be able to push it back into the machine, back into the learning, and continuously improve what that is. Now, another side is this is all done autonomously. And so intervention on my behalf or Rick's behalf can happen. AI, machine learning is a tool, but it also allows it to happen much quicker. And the expediency for scenario planning is really one of the drivers and key benefits that we're gaining. A couple examples on the next slide. So we understand all of the inputs. We're trying to figure out and reduce the variability within each of these. Classic point, we had one client where I'm just even looking at which SKUs out of 100,000 SKUs should have automated reorder points. We don't always want to have automated reorder points for every SKU because maybe we only have a min-max of 2, that SKU cycles, once, maybe 6 months, maybe there's warranty issues on it. And so we want to be able to manually intervene when we purchase that, if we want to purchase it. And so we were able to decide and detect which SKUs should have those automated reorder points. Taking those reorder points and looking at lead time variability, we were able to reduce the variability, or really improve the accuracy of those lead time reports by 85%. And so they purchased a SKU. Vendor would come back and say, yeah, great, it'll be here in 30 days. The reality is back in 2021, it wasn't 30 days. It was maybe 100 days. And so using the algorithms, using the external data sources, we were able to predict that, no, the lead time's actually going to be between 90 and 110 days. And so it's great on the reporting aspect, but now we can have proactive conversations with our clients. And that really drives that trust and potential new revenue options. We can actually look at rescheduling work orders and the work that has to get done that's based on those SKUs. And so just understanding that visibility and having that clear picture around what's going on for all of these forecasting or sensing inputs drives huge benefits. So just another couple of examples on the next slide here. One, we were able to reduce the inventory forecast error by up to 20%. And so, not the large company of $400, $500, $600 million, but within $100 million, we were able to look at $40,000 to $50,000 on a monthly basis of reducing overstock, just clearly based on some of the additional factors. Now, forecast error doesn't mean just we order too much, right? It means we also are going to order the stuff we need to fulfill those orders again. And so inventory forecasting is one of those drivers that Rick mentioned at the very start, that yes, it impacts gross margin and saves dollars, but it also drives net new revenue opportunities. And so again, understanding these data components and getting to that minute details of what makes a forecast, all of these savings eventually add up to, if I put my old Big Four consulting hat on, we go into organizations and say, we'll save you 8 to 10% by doing it this way. The reality is it is 8 to 10%, but it's 8 to 10% based on 100 different inputs. And so now we're looking and focusing on exactly what those inputs are. If we go to the next slide, we've talked a bit about the items, just products themselves. And I don't want to forget the service side of business, because on oil and gas and many other companies, services, equates for probably about 80% of your overall spend. And so now what we can do is look at service workflows and understand, okay, yes, we need this part. Yes, this asset requires maintenance, but what additional parts do we need to be thinking of for that repair job? I know I love working on cars. Doesn't mean I should work on cars, but I love working at cars in my garage. And it's frequent that, a 5-minute, 20-minute repair job ends up being a full day. And it's because something happened with the bolt and I got to go back to, Home Depot or UAP and get a tap and die set, get a new bolt, get something for the car. And there's probably multiple trips in there. So obviously we don't want Brent working on your car, but what I'm saying is, if I finally figured out that for a certain type of repair job, I'm going to need not just the part, but a whole bunch of different critical parts, almost like a kit, then AI can start kitting what these repair components are for these service work orders. If I don't need it, I can return it. If they don't need it in the field, they can return it to the tool crib. And so, using AI to not only predict what we're going to need on the item side to order the item, but also how are we going to enable our service function, our field staff, to make a lot more efficient decisions by having the right inventory at the right time, at the right place, throughout the network. And so if we jump to the next slide, Rick, we've talked about a couple of components that make up that visibility side, having the visibility to enable prediction, to enable scenario planning. And then that scenario planning fits on what we would call a digital twin platform. And then we can actually start looking at, what happens if, and make real-time decisions on the risk mitigation. So there's that component. And then there's actually managing the inventory through AI within your network. And so it's not just getting the inventory into your network, but it's what do we do once it's in the network? Perfect couple examples are using computer vision and quality control and maintenance on certain parts that come in, or even down to inventory counting activities. When I was in industry, I had the pleasure of counting pipe and laydown yards at -30. So there's obviously a safety component there and efficiency component there. And so computer vision would allow to take that picture and not only count how many pipes are in the stack, but if you took it straight on, you'd be able to calculate what the length of each pipe is. And so anyone familiar with a single random length or double random length piece of pipe knows that can, create a lot of variance on our final inventory counts if you're not measuring everything. Another opportunity would be to embed AI around the warranty work, around critical spare parts. So a lot of the problems would be having a service order and either not being able to find the part in the system or just not knowing that there's a warranty associated to that part. And so we're essentially doubling our spend by going out and buying a product that's already there, or just buying a product because we didn't know it was under warranty. And so we can link warranty work to critical assets and have that visibility as to where the inventory is in the system. So we can then make a decision of, it's going to take me 3 days if I order it from our warehouse down in Houston, or it's going to take me 2 minutes to get it across the street. Now we have a value-based decision to make. And that's where your decision comes into play, but at least you have the information to make those real-time decisions. And then the last would be, whether it's retail or any other industry that has multiple nodes of inventory, would be to predict the demand of customer demand prior to the inventory being there. So I understand the pull concept, but if we can use prediction modeling to understand where a product should be before it's ordered, it actually allows us to consolidate the orders, so we reduce our last mile costs. It allows the real time and the customer to have that trust with us that the inventory is going to be there when it's needed. So all of this is, all of these are fantastic opportunities of how we can embed AI into our programs and into the day-to-day strategies. But you can't just do it without the unification of data and understanding those data components. And so I'll pass it over to Rick to kind of walk us through some of those concepts and context.
Yeah, thanks, Brent. As Brent was talking about, we're talking about putting an environment in place where we can actually have a network of applications and embedded AI where you can actually have proactive management. You could actually start to do some scenario analysis and enable a digital twin of your supply chain, so you could actually maximize resiliency before something happens. And then, as Brent mentioned, improved asset utilization and overall visibility of the supply chain. So it's a network of components. It's all underpinned by data. The issues that we typically see is as you go through this, whether you're a producer manufacturing something or you're a retailer accepting finished goods from that supplier, that producer, there's data all over the place. For example, there's data here for returns and for customer information. There's demand chain forecasting applications or merchandising applications that are at the retailer. There could be logistics information that have to do with retail goods or finished goods coming from the distribution centers. Same as logistics information is coming from your suppliers. Again, sad part about these are all separate, disparate data. We call them data marts or data really captive in a data application. So as production pushes stuff to the retailer through the distribution center, there's a demand pull as well of what customers are buying and purchasing at the end. So really, there's all kinds of insights, all kinds of dollars and cost optimization as well as revenue opportunity throughout the supply chain. Typically not well integrated into a network because the data is unintegrated. So obviously, what we recommend is start to unify your data set, right? Start to unify your data into some kind of unified data set. We show here that obviously we work quite closely with all the big hyperscalers. So a lot of the target environment to begin to build that integrated data set is in the cloud. And you have a hybrid cloud sometimes because the comfort is there to basically maintain an enterprise copy as well as get that up into the hyperscalers like Microsoft or AWS or Databricks on one of those two providers. So what we see is customers picking where they want to start, right? Maybe I start by getting my supplier data, my finished goods data. I actually get some contractors that are actually perhaps finishing a product, for example, maybe printing a brand on a roll of particular paper or fabric, for example. So getting all that together, getting your customer data together. What we see is customers are looking for now opportunities to start with one of these applications, begin to build this unified data set. Perhaps you actually start with demand forecasting at the retail end or at your production end, and then integrate that with all the ERP data and other performance data that exists within your market, your environment. But start that journey to begin that data set. Look for opportunities to actually start grabbing data, even though you may not be using it right away, but build that enterprise data view, both from actual data, transactional data, as well as perhaps the metadata that's associated with that as well. So we see people moving to this. getting this unified view, this complete 360 view of their supply chain, understanding that all the network components that exist in it, and then getting that in an updated version in the cloud, so they can actually start to provide some applied AI to that. So typically, where do you need to start, right? We just say just start small, put a roadmap and a deep dive about how ML can be prioritized across your supply chain to actually maximize value for you. And a roadmap for, say, Brent's company is one way, and a roadmap for my company is different. As well, the unique data set that gets assembled in the process I described is different for Brent and different for me, even if we're in the same industry, right? So really got to focus on what that unique data set looks like and what the actual AI roadmap is to maximize revenue generation and cost optimization as well, gross margin optimization. With the goal of getting some model development done, get that initial MVP up and running, so you can actually start to experiment and actually start reducing that time to value from AI and machine learning for your business. And then the goal is to integrate a fully functioning system. That maybe the ML solution has a variety of ML machine learning environments throughout your supply chain, but integrated by data and integrated vision across the whole supply chain. So we recommend start in something that's digestible. Look for those data opportunities where you can start to build that enterprise view or 360 view of your supply chain, and get started with those small successful engagements. So we're AltaML. We're trying to apply AI to elevate human potential in positive ways. We're really pleased that you spent this time with us. And Brent and I want to thank you for your time. I think we're probably slightly ahead of schedule. So what I'll do is I'll stop sharing, and then we'll open up the floor for questions from you guys. Thank you very much.
Wonderful. Thank you for sharing your experience with us, Brent and Rick. A quick reminder to get your questions in, as we will now be starting the Q&A section. We'll start off with some questions that came in during the presentation. So to kick off, you mentioned talent at the start of the discussion. Can you elaborate on how organizations are overcoming that with the war of talent? Brent, can you take this on, please?
Yeah, thanks. The war for talent. So there's two sides to this. There's the the pure ML side, which we'll touch on, and there's also the digital enablement all through kind of supply chain, everything on the supply chain side. So part of that is understanding what your roadmap looks like and what your strategy is going to entail and the tools involved, right? And so is it robotic process automation? Is it Power BI with a visualization of Tableau, or is it actually starting to use AI and ML? So some organizations, just from a strict supply chain analytics side, are looking into their ecosystem and are partnering with universities on anyone who has a supply chain major. So there's a couple of oil and gas organizations I know of in Calgary who are doing exactly this. And so they take those students almost like an internship. They run them through their analytics lab, and they kind of develop and upskill those skills specifically on the digital supply chain kind of enablement group. The other side of that equation is exactly what we're talking about today, which is the ML and AI side. And so AltaML does something similar in that we have a service offering which is called the Talent Accelerator. But essentially what we're doing is we're working with local universities or universities throughout North America to identify potential candidates who have masters and PhDs who are interested in ML, want to learn ML, and come and work under the guidance of our senior leadership on use cases with organizations. And so those organizations have almost like a lab, if you will, where we're continuously ideating and reviewing use cases and validating what's going to drive value for the organization. That talent pool of the associates that are working on those use cases, if you will, from those local universities, at the end of their cohort, become a talent pipeline for the customers and for us. And so we're actually similar to the oil and gas companies who are doing it strictly for supply chain. It's looking at the ecosystem, understanding what that roadmap looks like, and then defining kind of that path. And a lot of it does have to do with upskilling of the associates or the university members. So I would start with where's your path, what's your roadmap, and what technologies are you looking to enable?
Great, thank you, Brent. Another question for you. How does inventory management fit into a digital twin solution?
Okay, so a digital twin, if we think of it as a platform, everyone probably understands the metaverse that Facebook or Meta is creating, and it's essentially a digital replication of, it could be a plant, it could be your entire network. It could involve, suppliers through tier 2, tier 3, as much intrication as you want to get. Inventory would then be a component in that digital twin. And so this is where I was referring to scenario planning. If we understand all the components, we can actually start modeling how inventory reacts and how long it's going to take to ship from one location to another location. What's the potential expediting costs of moving it from one location to another location? So it's having the platform and then building the analytical pieces on top of that platform. Inventory analytic pieces being the predictive nature, which we talked about around demand sensing, understanding the excess inventory, the cost of future excess inventory, where we might potentially want to move it to, and all the asset costs that are involved in that. So inventory demand sensing is a component of a much larger supply chain digital twin solution.
Great, thank you, Brent. Question for Rick here. Given the recent volatility in supply chain, greatly based on circumstances that are not typically the norm, i.e. reduced distribution capabilities because of the pandemic and Great Resignation, how much historical answers and inputs are needed to determine the rules? And given the incredible state of flux, how many models might be needed to establish future best practices and rules?
Yeah, it's a very good question. I think certainly, like any of the forecasting methods are traditionally used in the supply chain and in AI, they require a good view of the data within your business. So I would say that as long as you can strive to have as much of that 360 view as you can, and we'll give you some tips on maybe how to start if you're not there yet. But you're going to need, probably somewhere around a rolling 36-month kind of view of data that actually supports your supply chain. When it comes to the actual models itself, this is what really makes data so machine learning so unique, is that rather than kind of a fixed model, it's an AI driven, data driven kind of model. Shifting data will mean that the distribution of that model has learned and will change over time. So you need to retrain and fine tune those models that are learning those new patterns. Sometimes, depending on what kind of machine learning ops or AI ops you have out there, companies will put multiple models that are actually trying to predict the same thing and try to do a survival of the fittest. So, sometimes it's 2, sometimes it's 3, but there's always a primary model that may actually, through the tuning process, drop down to number 2 and another one drops up, for example, right? So again, all data driven as it learns from what's going on in your business. If there's an issue with a particular supplier, if there's an issue with people resigning or people not being there. So the frequency that retained or typically can be determined based on triggers from other monitoring systems that capture these drifts, right? So you would typically try to range of training data that's out there, perhaps have some, not only some a good view of external data and internal data, have a combination of that, but the idea is that you're going to periodically go through some retraining. So how many models and that actually need will be kind of contingent on what you're comfortable with, but you can actually set up your AI operations to have a couple of models competing to give you the best answer as it learns from new data.
Great, thank you, Rick. Another question for you here. What do you recommend we do if we don't have perfect data? I think this is probably aligned with the last webinar you hosted.
Yeah, you know what? I think the key thing, if it's not perfect, start small. Like start with a well-defined step to say, I'm going to focus on demand planning. I'm going to focus on, the demand planning either at the front end or the back end of my supply chain. Pick that and get started. It's really important to also look for potentially applying AI to gain value from existing data while collecting more meaningful data as time goes on. So, I know one customer where he was working on a small, marketing opportunity to do his predictive modeling, but had an opportunity to pull in, instead of just 200 elements, pull in 20,000 data elements and its associated metadata. So he took the opportunity to grab all that because he knew, even though he was solving a smaller problem, there was going to be predictive models and other just analytical applications that could use that data in the future. So he wanted to set himself up for success by grabbing all that data and then working with clients to see. Because then if you think about it, you could get in a scenario where, and this actually happened for him, where a new business unit came in and said, hey, I want an application. I looked outside the market, it's going to cost me $2 million. It says, well, I have all that data. And they actually implemented a solution for over a weekend. So once you actually have that kind of driven approach to, hey, I'm going to devour data, get my organization set up for data success and analytical success, there can be, I think some real opportunities for that. And then prioritize vendors and suppliers that actually bring data. We're working with logistic companies that actually have a bunch of data that they could actually bring to the table that get you weather data, get you, route data, that kind of stuff. And, so prioritize vendors that can actually bring you some opportunities to, give you more data to help your business.
Great, thank you again, Rick. I'll move to a question here for Brent. How is machine learning helping with pandemic-caused disruptions?
Yeah, I think a couple of points to that, and I guess it's how broad do we want to cast that? But we have, I hate to say it, we have a couple of years worth of pandemic data now, and so we can start looking at historical trends around patterns from suppliers, around lead time, around what's going on in the industry in terms of which materials are we short of. If there's a shortage of aluminum again, which there was about a year and a half ago, and that disrupted a whole bunch of the paint side business, what implications of natural resources or even components are out there? And then we can start feeding that into the model of understanding what's the impact around, whether it's inventory or whether it's transportation routing and congestion at ports, and what is that going to do to impact our lead time. So a lot of it is just learning the patterns over the last couple of years, but it impacts everything from the inventory, which we briefly touched on, the network and understanding the transportation routing, warehouse management, and maybe more internal to an organization, but how many organizations had issues at their warehouse because there was a COVID scare and they just didn't have the people to process the orders. So, how is AI and automation within warehouses now impacting those organizations? So machine learning is a component. Again, it's a tool of supporting decisions to make while we're going through this. But I think, the large scale is, if you can plan it, if you have the data, and then you can go ahead and plan it, and scenario plan out all your options, then you can actually start making a lot more informed decisions. So machine learning is available to go all over the place. We kept today's discussion on the inventory side, but there's definitely applications, from rating and ranking a supplier. And as Rick said, maybe one of those components is that they're willing to share their data. And so you can get their inventory forecasts all the way to the reverse logistics side. And how are we going to move this inventory or this dead asset afterwards?
Thank you, Brent. We have a question here about what rules of thumb might you use to evaluate potential corporate investment required to begin down the path of ML? Rick, maybe you can take this one.
Yeah, I think we kind of talk about this in our own methodology. Before you make any investment, certainly in machine learning and AI, I always say let's go back and just start with a pencil. Like, write down the value that you think you're going to get out of it, right? So focus on understanding the value of the whole solution, the value of, if you're going to talk about, the supply chain, which can be complex and expensive. Let's think about how we're going to do that, right? The value potential, and make sure that there's, a shared expectation of what that potential value is. And, so that's a start. Start with a pencil, write it down. I know it's kind of goofy to say that, but I mean, obviously get in a net present value of what you think the opportunity and the investment would look like. And then start with small bets, as we talked about, right? Don't, build it and they will come. Start with a small bet, generate value. And why that's important is you start to get a collection of supporters, of people from the business side that say, hey, Brent did a great job. That I already seen value very, very quickly. We're starting to see, traction. And then you actually get, that'll be a self-fulfilling prophecy to get more money. And then, build experimentation into what you do, right? Machine learning and AI are experimental in nature, meaning the idea is get new data, experiment if this particular model works. So keeping that philosophy of failing fast is critical, learning fast, adapting and pivoting is really, really important. And it's also really important that you make sure that's built into how you communicate with with your executives and the people that are writing checks, is that there is going to be some experimentation, and we may have to backtrack and try a different approach because that didn't work, right? So just by the nature of how machine learning models are built and how data gets assembled within your business, right? So it's pretty important to make sure that's built into your overall capabilities. And I think there's multiple capabilities that you're going to need within your organization, data, people, so it's interesting also to write that down or get that into a Venn diagram so you can actually understand all the capabilities you have and don't have, quite frankly, to make sure that you could actually have your organization set up for success by filling in the gaps and taking advantage of your potential strong suits as well. So good question.
Okay, thank you, Rick. We have a question here for Brent now. How can you use AI to determine the lead time of ordering goods from a supplier when forecasting, and what can be done to avoid bullwhip?
Yeah, so this comes back into the learning of patterns for suppliers. And so we can take a look at, our internal data around what a typical lead time has been historically for a supplier, and even down to certain components, because they might have different shipping points for different types of products. And so it's understanding what their historical impact internally has been. And then it's also looking at where that inventory is coming from and taking consideration what those external factors are. So again, is the port tie, is the container ship tied up right outside of the port for another 3 days? And is there still that congestion there? We can start looking at what impact that's going to have on our lead time. I think so it's looking at those two data sources. In terms of the bullwhip effect, I mean, that's understanding what you have on order, what is already, it's kind of the classic inventory side. What's already on order, what's already allocated, what the appropriate min max is, because, and I can see a lot of it happen for some companies when it came to masks last year, right? They didn't have enough. They ordered containers and containers and they showed up. And then when it dipped for a little bit of the summer there, it was a fire sale for inventory. And so it's staying true to the algorithm and trusting the data and trusting the machine learning process, if you will, to have those outputs and actually not override those outputs. And that's where I've seen a lot of issues, actually, even using advanced Excel forecasting models, is there's an output and then someone has a gut feel and then they go and override that output. And 9 times out of 10, they should have just remained with what the original prediction was or the forecast was. And so it's trusting the model, but you have to have the right data in order to put in that model. And to the first part of the question, it's understanding where that inventory is coming from to make sure you have the right components. And again, that gets back into the what is visibility for inventory. It's not just understanding that you have 8 pieces of widget X in one location. It's what's that look like throughout the network, and how long is it going to get to replenish?
Great, thank you, Brent. I have another question for you on how 3PL is taken care by AI.
Third-party logistics. Okay, so there's actually, if we look at the transportation side, there's some really interesting developments, if you will, that are coming out of the 3PL transportation route. And so brokers now have always had the ability to look at, if you want to ship something from A to B, what they'll do is they'll put it up on a website and you can select the carrier you want and they'll deal with it. And if there's consolidation on the back end, they'll deal with that as well. What we're seeing right now, and there's an organization based out of Vancouver here, it actually allocates and it provides you what the GHG is for that transportation route along with the price. And so in terms of 3PL, we're going kind of that next level already around how do we use AI to support ESG scores and support the reduction of greenhouse gas and climate initiatives. So that's one example around understanding what that route looks like and all the impacts and stops around that route and what your total GHG impact is by selecting that carrier. The other side of AI is around that warehousing. And so, there's AI within the warehouse that can be used with automated robotics and lights out facilities. And then there's understanding where the nodes are of those 3PL. So if they have multiple locations, we can start looking at, again, that demand sensing where the inventory might need to go ahead of time and allocating and redeploying the inventory ahead of time. So that last mile shipment from, location to customer, which is normally 10x the cost of any other transportation within the system, is significantly reduced because you're not hot shotting from, a further location. And so AI is embedded both on that internal and external node, if you will, on predicting where the demand is. And it's also now being used on the GHG and implementing for improving everyone's ESG scores on the transportation side.
Fantastic. Thank you, Brent. I've got a question here now for Rick. What are the best practices to focus on when embarking on an AI-enabled supply chain journey?
Yeah, I think I hinted at one of these at the beginning. Is I think what we've seen and it's in our methodology as well as many methodologies out there, is that identify value clearly before you start any development at all. Before you actually start, machine learning developers or programmers working on things, understand the clear value of the project and the value of the entire, say, AI-enabled supply chain solution you're working on. Get that pencil out, start actually working with your line of business people, your supply chain executives, your operational executives, really figuring out exactly what the overall value would be. And then when you actually start designing that solution, make sure it meets the needs of your business before you start engaging suppliers like us and vendors, right? Make sure that needs of your business are figured out. As you said, as I was saying before, Brent and I may be retailers, perhaps even in the same country, that have different needs, right? It could be two grocers that have different needs, different customer sets. So once you actually start building that unique data set and that unique solution, they may actually get deployed slightly differently or significantly different based on the business model. So really understand, get that engagement to make sure those line of business people are engaged, to make sure that they're the solutions are being met and created for them, not just pulling a solution from a vendor to solve the problem. And then I think it's alignment of goals and incentives. I think that's probably the big thing for everybody, right? A lot of times we don't line incentives together when we actually start working with these solutions. I mean, line of business executives, supply chain executives, IT executives, and by the way, vendors and system integrators like us. Make sure that we have all goals are one thing, but make sure everybody's incentives are aligned too. I hate to say this. I mean, when it comes to payments and money and people's paychecks, that's how people will get measured. And if it gets impacted positively as a result of it, you'll get more and more better results. Negatively, if it's not done right? So I think it's important to make sure you have alignment of incentives and the goals as well. And lastly, like we talked about, what's that Venn diagram to address your capabilities and skills gaps within your organization and marketplace. So as we know, there's just a complete lack of talent, not just abundance of talent, not lack of talent, abundance of talent in the AI machine learning business. So figure out how you're actually going to build that talent up within your organization. And to be self-serving, we have talent accelerators that we can implement for people to actually help with that. But that's a very, very big problem. So make sure you've got a plan to address the skills gap within your organization as well. Those are the 4 best practices I could see.
Great, thank you, Rick. We've had a question come here through the chat about how is aging of material taken care of? Rick, would you be able to answer that one?
I could take a quick stab at that. I think this boils down to forecasting demand again. Whether I'm a manufacturer forecasting demand of what I'm making to tying what I'm making to the forecast of a customer in a retailer buying what I'm making, right? So I think it's really important to have if you could actually figure out that I've got some slow moving items, I got items that aren't selling. So, having a proper set of data and demand forecasting solution, we can build analytics to actually predict when to order or to not order something. And then, by the way, there's other things that we can look at too. Once we get that historical view of all those metrics and find out what's turning and not turning, we could also build some AI to perhaps do markdown planning, right? If I'm a retailer, I can actually start to predict what's the best way to do a markdown or a price markdown to get that off the shelf without impacting other related products. For example, if I'm a retailer selling, makeup goods, for example, if I discount one lipstick, you got to make sure that I properly plan for that so it doesn't impact some other high moving SKU item as well. So I think again we can properly apply data to it, and then also make sure that hey, I got a slow moving item. Just realize it's a slow moving item. It's not out of stock, and make sure that you tie your ordering processes to that as well. So it's you're not buying too much and maintaining that inventory turnover an effective basis by making sure you are focusing on those 20% of the products that have 80% of the demand, either in your manufacturing process or on the shelf in a retailer. Good question.
Maybe and just to support Rick on that one, it's really about making sure you don't have it, which Rick mentioned. But in addition to that is forecasting in advance what is going to turn into excess inventory or non-moving inventory, and being able to predict that and have a plan. I mean, there's different options that you can look at as strategies to actually remove the inventory from it, whether it's markdown, whether it's having contract agreements with your suppliers that once a year at 4%, whatever sales were from the previous year, you can return 2% of that non-moving inventory just so it keeps going. There's a whole bunch of different methods to actually get rid of it. But as Rick mentioned, it's stop it at the very start through proper forecasting. And then before it gets to that point, be able to predict what is non-moving and where it potentially could either be redeployed or there's a reverse logistics process for it.
Great, thank you both. We have a question here about how analytics have always been a big part of supply chain and demand forecasting. But what is different about AI and machine learning here? Rick, can you answer this one?
For sure. Many of the forecasting engines used out there before, if not manual, are based on predefined models that already exist out there that take a best fit approach to making an order or an inventory prediction, right? What we've been talking about is really AI and machine learning are data-driven, learning-based models that will improve their recommendations and almost improve their beliefs as new data are consumed in the learning process, right? So it's very different. And then another thing is many of these existing models that are, these best fit models, a lot of them are black box. You can't see into them and understand the mathematics around what's going on. We're big in our organization. We call it responsible AI. So model transparency and explainability are really important to us. So we can actually explain in English terms to a business person, this is how it's working, and you can get agreement on the transparency model. That doesn't exist in some of the models. So I think the fact that it's learning and changing its beliefs based on new data that's coming in, being retuned, is very unique with the AI and machine learning opportunity. And you could see that there's significant value improvements that are happening both in cost and gross margin, say, improvements, as well as revenue improvements as well. If you can get a 10% reduction in cost, as well as a 10% increase in revenue, that's a perfect scenario, right? And then machine learning can consume highly dimensional data from a variety of sources and detect very, very, very complex patterns. That's very unique. I mean, if you look at some of the things we're working on, we're looking at different types of data. We're even looking at visual data to actually improve the manufacturing processes, as Brent was mentioning, whether it's improving quality or reducing scrap or detecting a particular maintenance problem. Yeah, so I mean, I think in many cases they'll use summary data, some of the old models, and have experts looking to determine what the next move should be, and that's hard to scale, right? When you look at some of the previous ways of doing things, where we're looking at ways that the actual detailed data within your business can actually drive this learning environment, this robust machine learning driven process that have models that reiterate and learn the best rules for the current situation you have. Good
Great.
question, thank you.
Yeah, thank you, Rick. We have time for one more question. So we've had one come through that asks, how can AI be incorporated into inventory management in the warehouse when using warehouse management system? Brent, can you please take this one?
Yeah, thanks. So I guess the first question is, or first point is, I hate sounding like an ex-consultant, but I gotta say it depends. It depends on how advanced the software is. So if you're using state-of-the-art Manhattan or SAP EWMS versus off-the-shelf tier 2, tier 3 system, you're probably going to have some different intricacies around what you're able to do and what data you're able to take. But a couple things right out of the gate. Even with an automated system, if we think of the flow of inventory into the warehouse, even with EDI and other enablers, there's still a lot of time where individuals are going to check a physical packing slip and want to record notes on it if it's damaged and either type it into the system. So what we can do is actually use natural language processing to read the packing slip once it's actually there, or potentially read the bill of lading. Any documents that aren't flowed through the EDI enabled network or system, you can actually tag those notes directly onto the item that will probably have kind of like a catalog structure, and put that right into the system. So next time somebody pulls it to order it out, they'll see all the notes, they'll see all the paperwork, and they'll actually be able just to quickly kind of file that paperwork away. And it goes on the other side too, where it's reconciliation of bills of lading, which is one of the most time-consuming activities. So once the inventory is going out, you can automatically reconcile and push that to invoice payment. So that's kind of the bookends of it. And then once it's actually internal, it's log and stream the data. If you have a dynamic put away system, so dynamic shelving, and that item doesn't always go into the same location, the system will pick whichever one's best. You can look at, you can start training it around what items should be grouped together, almost like a kit, or what items are frequently ordered together if the system, again, isn't advanced enough to pick those all at the same time. Yeah. Automated system, you're going to have your defined pick paths, but taking that data and putting it as to an extra level on efficiencies within the system is going to be a giant gain as well. Great question. Thank you.
Great. Thank you, Brent. And with that final question coming through, that brings today's webinar to a close. If we didn't get to your question, I encourage you to reach out directly to today's presenters, whose contact information will be sent out with a link to the recording and slides shortly. Please share your thoughts on today's webinar through the survey displayed at the end of the event. Brent and Rick, if you have any last words you'd like to share.
Just a big thank you to everybody attending. I'm just seeing there's not only there's a great audience, international in flavor. So thank you so much for your time.
Thanks, everyone. Appreciate taking the time with us today.
Great. Yes, completely agreed. And a big thank you to you, the audience, for making time to view this presentation. Until next time, have a great day.